have a few proofs on the text. Now, like I said before, proofs are set up a couple different ways. This particular proof is set up as a multiple choice. We've got two things in here missing, line 4 and 5, line 5, and they give us the possible choices for line 4, line 5. So that's one of the possible ways that they can set up a proof, is just still do it as multiple choice. Some of the other ways, as I said before, they'll give you all the choices, and it's kind of a drag and drop sort of thing. Or I've seen it where you kind of click here, and then it gives you like 3 or 4 choices for each line. This particular one is just 1 point. This is a multiple choice. So we have Marcus proving the Pythagorean theorem. Now that's a key thing right here, is because it says Pythagorean theorem. So what's the Pythagorean theorem?
A squared plus B squared equals C squared.
Right. A squared plus B squared equals C squared. He draws the right triangles. So basically what he's saying is, this triangle is similar to this triangle similar to the whole thing. So I have 3 similar triangles. That's what he kind of went through. And because I have 3 similar triangles, I can figure out the Pythagorean theorem. So that's what this is saying. I've got similar triangles because of the angle. Because they're similar, I can set up proportions. So I know these 2 sides are going to be equal to these 2 sides proportional. These 2 sides equal to these 2 sides proportional, because similar is always proportional. If you multiply diagonals, I know jk times jk is jk squared equals these 2 multiplied. Lj times Lj is Lj squared equals to those 2 multiplied. Multiplication property of equality. You can multiply diagonals. Now, that's where they kind of left off. But it did say something about Pythagorean theorem. And we know Pythagorean theorem is a squared plus b squared. So it looks like they took the squared part here and the squared part here and started trying to come up with an equation. Now, something squared plus something squared times something squared, plus times. Well, if I'm going to somehow get Pythagorean theorem out of this, it's going to have to be a plus in between, because that's what Pythagorean theorem is. So that means these 2 don't make sense, because they have a multiplication between the squares.
It's not
B, shut up.
It's not D either.
So which one is it?
B.
It is B.
Yeah.
No, actually it's not. Sorry.
Oh my.
A.
It is A. Because the rest of this line is the same. This one, we're using distributive property. So LK times MK, LK times ML, that's what they had here, as opposed to this one was LK times LK, LK times LK. But that's not what this is. So it's got to be this one. Because this one had the correct distributive property, this one didn't. So that's an example of how they might do a multiple choice proof. A multiple choice proof. Let's look at the next one. Eight, 9. 8. It says cosine, which is a trig function. Anytime I did anything with a trig function, I marked the sides first. So which side is the hypotenuse? 17. It says I'm going from A. Which side is opposite? 15. So if I walk to the other side, that's the opposite. So this must be adjacent. Now on your reference paper, it tells you what cosine is. Cosine is adjacent over hypotenuse. Adjacent was 8. Hypotenuse is 17. That's it, you're done. Sometimes I have students trying to go further and trying to find out how many degrees angle A is, but that's not what it says. It just says what's cosine. It wants to know the ratio for that angle. It wants to know the cosine ratio, and that's all it wants. every test, I have seen one of those. That is always on every test. It may not be cosine, it may be sine, it might be or tangent, but there's going to be one of those on the test. That is one of the easier ones. It's not hard to figure that one out. Now, number 15, it's kind of tricky because it took me even a little bit to kind of look at going like, how are they expecting us to do this? What do we need to do? So the total of 50 students played either soccer or lacrosse. 20 girls played lacrosse, 20 boys played either soccer or lacrosse, 20 students played soccer. So the first thing I started thinking is like, well, we've got soccer, lacrosse, we have boys, girls. Let me see if I can kind of wrap my head around this using a two-way frequency chart. They don't give us one, but I can set my own up. So that's what I'm going to do. Is I'm going to set up a two-way frequency chart that has girls, boys, total, soccer, lacrosse, total. So there's my frequency chart. Now I can start filling in what they've told us. I have 50 students total. So 50 goes here. 20 girls played lacrosse. So girls lacrosse was 20. 20 boys played either soccer or lacrosse. So that's the total number of boys they talked to. So boy total was 20. 20 students played soccer. So soccer total 20. So those are all the numbers I gave us. Well, using those numbers, I can fill out the rest. 20 plus 30 is 50. 30 plus 20 is 50. 10 plus 20 is 30. 10 plus 10 is 20. 10 plus 10 is 20. So there's my chart. Like I said, they didn't tell us to do a two-way frequency chart, but it seemed to make the most sense. Because I have two different things I'm comparing. I'm comparing boys and girls, soccer and lacrosse. Now, the question says, what's the probability that a student plays soccer or is a girl? Or. What do I do with ors? I have ands, I have ors. What operation do I do for ors?
You multiply.
No.
Divide.
Ands are multiply.
Oh.
Ors are add.
Subtract. Oh.
Add. Or is add. So I have to take the probability of soccer plus the probability of girl. Now, is there an overlap on this one? Could I possibly have kids, students, children that are in both soccer and girl category?
Yeah.
Yeah. So now I have to subtract the probability of soccer, girl. That's the one probability formula that they give you on the reference paper. Probability of A plus probability of B, subtract probability of A and B. It's the one they give you. So, probability of soccer. How many played soccer? So that'd be 20 over 50. Plus, what's the probability of girl? How many girls are there? So 30 over 50. Minus my overlap, which are soccer girls. How many girls play soccer? So subtract 10 over 50. 20 plus 30 is 50. 50 subtract 10 is 40. So 40 over 50. And you can just leave it like that. If you want to reduce to 4/5, you can. If you want to divide to 0.8, you can. But you don't have to. Like I said, that one's not an easy one. That one's even a hard one to even try to figure out what exactly they want us to do. So definitely on the easier ones, be careful and get your points. Like this one. This one should be an easy one. This should be an easy point for everybody. This one's a bit trickier. Moving on. Now, number 9. Like I said, there's a couple of concepts that just we didn't get time for. This is one of them. You actually did this back in algebra, but I know algebra was a long time ago. So I'm just going to kind of talk you through this. Some years they don't even put these on the test. Some years they do. So if it was something that didn't get hit, I figured this is a good thing. It's talking about an equation of a line. So if it talks about an equation of a line, automatically I think y equals mx plus b. That should have been just cemented in your brain from now. Y equals mx plus b. If they do have one, generally it's going to talk about a perpendicular. Perpendicular. So if my original slope is -5, the perpendicular slope is going completely the opposite way. So I have to change the sign and do the inverse, which is 1/5. That's my perpendicular slope. Now from this point on, it's just plugging things into equations. So I have a point here, xy. So y, which is 9, equals slope, which is m, 1/5, times x, which is 5. Right now I don't have a b, that's what I'm trying to find out. So 1/5 of 5 is 1. So 9 equals 1 plus b. Subtract the 1, I get 8 equals b. So y equals 1/5 x plus 8. Now, like I said, it's been a while since you've done that. In fact, this is one of the things I'm planning on doing after the test because it's still part of our curriculum, even though I didn't get to it. And it's something that you'll definitely use in Algebra 2. Because you definitely are going to do equations of line in Algebra 2. This one. This is one of the easier ones. Jeremy wants us to know the density of the rock in grams per cubic centimeter. Well, first they give me kilograms, but I want to know grams. There are 1,000 grams in a kilogram. So first thing I have to do is multiply by 1,000. And I get 1,080. That's my grams. Over cubic centimeters. Well, it says there was 400 cubic centimeters. That's my bottom. Divide. 1080 divided by 400 will give me my density. 2.7. I want to say almost every test has had a density question on there. They always give you the formula. It's not on your formula sheet, but they give you the formula. They'll either give you the density, the grams, or the cubic centimeters. They'll give you 2 of the 3 you saw for the third one. It's just an equation. It's all it is an equation. I'm not even real positive why they stick it on the geometry test, because it doesn't really have a whole lot to do with geometry. I could see it on a science test. I could see it on an algebra test. But they stick it on geometry. But it's not a hard question. You just plug 2 of the 3 numbers in, solve for the third. Number 12. 12 is an easy one. A real easy one. But you got to read it. The 2A table shows the number of births in thousands in the United States for years 2010 and 2011. A baby born in 2011 is randomly selected. That's the key sentence right there. What's the probability that a baby was born in February? So, what's my February?
299.
299, because I only care about the 2011, because I'm picking from 2011. Over,
3,966.
I wouldn't even try to reduce it. I wouldn't even try to divide it. Just leave it. That's your answer. That's it. That's it. So that's one of the easy ones. Like I said, definitely be careful on the easy ones, so that way you don't lose points on easy ones. This is an easy one. Like I said before, there's going to be 2-way frequency tables. If I had to lay a bet, there'll probably be 2 or 3 of them. There's always 2-way frequency tables. This question. we've got a shape that they somehow cut, and we want to know the cross section. This particular question, not this exact same question, but they always have something like this. On the 2019, it was a cylinder that they cut in half. This one's a cube they cut diagonally in half. Sometimes it's a pyramid that they cut the top off of. They cut it down the middle. There's going to be one of these questions. So this shaded space, which is the cross section, is what shape? Rectangle, rhombus, square, trapezoid. Which shape is this shaded spot?
Where?
That's what a lot of people have said, but it's not a square,
Rhombus,
not a rhombus.
then it's a rectangle.
It is a rectangle. Let me explain why it's a rectangle. A square and a rhombus have to have equal sides. Now, let's say this is a square. I got a square here. I've got the distance to there, distance to there. If I walk diagonally over to Carter, will that distance be the same as that distance?
No.
No. The diagonal is always longer. So because the diagonal is always longer, this diagonal will be longer than this one, which is part of the cube. So that's why it's a rectangle, is because the diagonal will always be longer. A lot of people have said square. So just be really careful when you're thinking through it about whether or not we know a distance is going to be longer, shorter, stuff like that. So that's this one. Like I said, there's always one of these on the test. They change the shape, they change how they cut it, but there's always a cross-section question, always. $18. Event A and B are independent. The probability of A and B was 0.25. And, how do I get ands? I multiply. So that's telling me that the probability of A times the probability of B was 0.25. So I have to figure out what two numbers I can multiply together to give me 0.25. Well, what two numbers can I multiply together to give me 25?
4 or 5 and 5.
5 and 5 will work. Make sure you just don't do 5 and 5 because that would be a straight 25. I need 0.5, 0.5, so that's one option. 0.5 times 0.5 is 0.25. Or maybe you made one of them a 1, and it doesn't matter which one. 1 and 0.25, because anything times 1 is itself. So that's another option. The other option, there's my cat letter, is if I did 0.25 and 0.4, or 0.4 and 0.625. Now you have to be really careful because if you get too small, like 0.25 divided by 0.2, you get like 1.25. Can I have a probability that's bigger than 1? Can probabilities be bigger than 1? No. So you have to make sure whatever two numbers you're picking, they can't get bigger than 1 because probabilities can never be bigger than 1. No. 19. There's always a question about this. Now, remember there's 3 different formulas for these, depending on how they look. This one, the angle touches the circle. It's the easiest of the 3. So if the arc is 120, what did I do to get to the angle? Anybody remember?
Wait, you said the arc is 120.
The arc is 120. What's the angle?
Don't you do 180 minus 120? No. Oh, that's for the side.
Yeah, that would give me this one and this one. I'm looking for the angle.
60.
What's that?
60.
It would be 60 because you divide by 2. Divide by 2, you get 60. So that's one of them. If the arc and the angle touches the circle, it's just half the arc. This is another one. If it crosses somewhere inside but not the middle, let me put an A here and a B here. Remember, this one was arc plus arc. Divide by 2 equals the angle. So if it's like that, you add the arcs, divide by 2. If it's like this, AB, then it was arc minus arc, divide by 2. Now, they're going to put one of the 3 on here. I don't know which of them, but there's always one of these 3, always. The key is you got to kind of remember which formula is which. So that's 19. You okay there? $29. 29 isn't too bad if you can visualize. Points A, B, and C lie on a circle with center Q. So I'm going to draw a circle, stick a Q in the middle. It says the area of sector AQB. So I'm going to make myself some kind of a corner piece of the pie. AQB is twice as big as BQC. So BQ, I don't want to go straight across for C because that's going to make them the same. I'm going to kind of chop it so it's about half as big and do C. So that's what it's going to look like. Something kind of like this. AB is 28. How big is BC? Now, once you have that picture, and you know that the area of sector AQB is twice as big as BQC, how big is BC? If this is twice as big as this, if this is 28, this better be. This is twice as big as this. So this is 28.
56.
Wrong way. This is bigger. So my question mark is going to be not 56 because that's getting bigger.
Oh.
14. Half as big.
I'll have it.
I wanted a smaller one. I just need half as big. Question there. Another proof. Yeah, still not quite small enough. That'll work. Now this is a drag drop. They give us all the different choices for and through here. So you have 4 missing things and a whole bunch of things that can go with it. It's a 2-pointer. If you can get 2 of the 4 correct, they give you 1 point. Now, let me kind of explain how you can hopefully get, even if you're not really sure, at least one of the 2 points. So let me kind of talk through this. This is a parallelogram. They told us that. The definition of a parallelogram is a 4-sided figure that the opposite sides are parallel, which is what this says. Then it's saying that angle ZWY, this guy, is congruent to XYW, this way. Now, I could go ahead and do this one, but I don't want to kind of clutter my picture yet, because I have to kind of identify what type of angles are those. So I'm looking for an angle relationship. So looking through here, corresponding angles, that's an angle relationship. Alternate exterior angles, that's an angle relationship. Alternate interior angles, that's an angle relationship. This is not an angle relationship. These are all my triangle relationships, and none of those are angle relationships. So I'm only really picking out of these 3. These 3 are my angle relationships. Corresponding, alternate exterior, alternate interior. Which one is that? Corresponding, they're in the same position. Alternate exterior means they're on different sides, but on the outside of the picture. Alternate interior, they're on different sides, but inside.
The corresponding.
Corresponding is same corner, and they're not in the same corner. They're going to be alternate interior. Alternate interior. So alternate interior. Because remember, if I did kind of the full picture like this, alternate interior is like this guy and this guy. So it's on different sides, but inside the shape. Inside the shape. Alternate interior. Now, maybe you struggle with that. That's okay. The next one. Well, let me go ahead and mark this one. ZYWXWY is going to be this guy and this guy. Now it's saying WY is congruent to WY. Well, that's that sheared side in the middle. It uses this triangle and it's part of this triangle. So that side's equal to itself. Now, anytime you have a statement that has the exact same thing on both sides, it's always, which one of those? Reflexive. So even if you struggle on this guy, everybody should be able to get reflexive. Because reflexive is always the exact same thing on both sides. Always. So reflective. So now I know that middle piece. Well, now they're saying triangle, blah, 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 is congruent to triangle, blah, blah, blah. So I'm using my triangle reasons. Well, my triangle reasons are here down the middle. It says anything about triangles being congruent, side, 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 angle, angle. It's one of those. So looking at my picture, side, 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 angle, angle, angle. Be careful. Do I have one angle and two sides on either side? Or do I have two angles and a side in between? It's angle, side, angle. Angle, side, angle. Angle, side, angle. So if it's talking about triangle something congruent to triangle something, you know it's one of those. Side, 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 angle, side, angle. You can at least get rid of all the other choices. Now the next one is one of the ones that, once I refresh your memory, it's an easy one to get. We have a triangle congruence statement. Then it goes one step further and says, well, because these were congruent, I know anything on the two shapes are congruent. Now this is the one that I did kind of the letters. It was a little song. C, P, C, T, C. Corresponding parts of congruent triangles are congruent. So if you have triangle congruent statements and something after, the something after is always corresponding parts of congruent triangles are congruent. They're not going to use the abbreviation. They're going to write it out. Corresponding parts of congruent triangles are congruent. So these two are pretty much a given. Same thing on both sides, reflexive. If we have another line after the triangles, it's CPCTC. So that gets you one of your 2 points. If you're struggling on the other reasons, you can at least get one of the two. Next. '23. There's 2 ways I can do 23. I can either use trig or I can use special rights. I'm going to show trig first, and then I'll show you the special rights. Trig. I'm going from this angle. That's the angle they gave me. Longest side, hypotenuse. This one has to be opposite. And there's nothing on the other one. So I know I have to use sine. This is definitely a sine. And I know sine is opposite over hypotenuse. So this I'm going to set it up. Sine of the angle equals opposite over, that's an A, hypotenuse. Make it a proportion. been a while since we've done trig stuff, but you guys did pretty good on the trig stuff. Most people got really good grades on the trig quiz. Multiply your diagonals. So sine of 30 times 44 equals A. Just put that in the calculator, you get 22. So we know this is 22. That's my answer. So that's one option. Your other option is maybe you go and go, wait a minute, that's a 30. So this must be a 30, 60, 90, which is one of my special rights. So if I look at my picture, here's my special right picture on my paper. So that's my special right, 30, 60, 90. The 44 is which one of these three sides? The x, the 2x, or the x squared to 3? The 2x. 2 times something equals 44. So x must be 22. The 22 is the shortest side. 22 is the shortest side. It's actually easier if you remember to use your special right triangles. But you can do it either way. Trig or special right, doesn't matter. Question there. This is the last one I'm doing for the day. Which term defines as two intersecting lines that form 4 right angles? If I have 4 right angles, do I have skew lines, straight lines, parallel lines, perpendicular lines? Perpendicular. It's just a straight vocab. Remember, skew goes like this. Skews go different directions and they're not touching. So they're kind of like parallels, but they're skew. Straight line is just straight line. I mean, it's not even part of anything. And perpendicular, they touch at 90-degree angles. They touch. Now, tomorrow, we're going to pick up where we left off. So tomorrow we're going to start at question 34. That's where I stopped for everybody. I'm just going to see what I can get through. I might not be able to get through everything. Yes, I realize that tomorrow is day 1 geometry, but I might be able to show you something that'll help you on day 2. So I'm still just going to go over things. Wednesday, after day 2, I'm not planning anything particular, but I am planning on passing out what's for Thursday and just giving an explanation because I'm not here Thursday. My son called over the weekend and said that he's up in Toledo, I think you guys know, and then Thursday is when he needs to come home. So I'll be picking up him. So Wednesday, I'm going to explain what you're doing Thursday, and then Thursday help us up. Yes.
Am I taking the state test?
Geometry?
Yeah.
Are you in a geometry class?
Yeah.
So you're taking geometry tests.
You know what teacher I have?
What's that?
You know what teacher I have for the test?
I'll get it. So let me stop this, and I will look it up.